Dear students, welcome to my channel. Topic of this video is Introduction to Image Processing. This is the sixth video on this topic. In this video, I am going to discuss connectivity between the pixels, and the topics covered are neighbors, adjacency, and different distance measure. Now let us start. Neighbors of a pixel N4P, that is 4 neighbors of P. Any pixel P xy has 2 vertical and 2 horizontal neighbors. So this is the vertical and this is the horizontal neighbors given by, so if this pixel is f of xy and this is y and this is x, so this location can be f of xy plus 1 and this is f of xy minus 1 and this is f of x minus 1 y and this is f of x plus 1 y. So these are nothing but the 4 adjacent neighbors of the pixel f of xy, that is given by these 4 coordinates. This set of pixels is called 4 neighbors of P and it is denoted by N4P. Each of them is at a unit distance from P. Now if we require to take the distance between these two pixels, so it is a distance of 1, this is the distance of 1, this is the distance of 1 and this is the distance of 1. So basically this is nothing but unit distance from F. Now NDP, 4 diagonal neighbors of P. Any pixel P xy has 4 diagonal neighbors like this. So their coordinates are f of x minus 1, y minus 1. This is f of x plus 1, y plus 1. Here x is decremented and y is incremented, that is x minus 1, y plus 1, and here it is x plus 1, y minus 1. So these are the diagonal neighbors of this pixel f of xy. Each of them is at a unique Euclidean distance of 1.41. So if we take the difference between this Euclidean distance between these 2 points, so we are getting the answer as a 1.41 from f pixel. N8 P, that is 8 neighbors of P. So 8 neighbors of P is nothing but the adjacent as well as the diagonal member. So this is the adjacent members and these 4 are the diagonal member. So total 8 members are there. So we can consider entire neighborhood of this particular pixel f of xy. So whatever the pixel present at adjacent location, they are at unit distance from f, and the pixels which are at diagonal neighbors, they are at a distance of 1.41 from this center pixel. It may happen that some of the points in the N4P, NDP and N8 may fall outside the image if it lies on the border pixel. So for example, if f of xy is at this location, so some of the neighbors goes outside the image boundary. Next concept is of adjacency. 2 pixels are connected if they are neighbors, but that is not only the sufficient condition, that is they must be neighbors and their gray level satisfied some specified criteria of similarity. For example, in a binary image, 2 pixels are connected if they are in either N4P, NDP, N8P neighbors or have the same value, that is either 0 or 1, because in binary image only 2 values are there, 0 or 1. So we can take the connectivity by either 0 or 1, but they should be neighbors and they should have a similar value. B is a set of intensity values used to define the adjacency and connectivity. In binary image, v equal to 1 if we are referring to adjacency of pixel with value 1, but in grayscale image the idea is the same, but v typically spans more range as gray levels vary from 0 to 255. So in that we have to pick up the similar intensity value when we are finding the connectivity between the 2 pixels. So for example, v is equal to 180 to 200. Now this value or this color intensity value is region is similar. So we are finding out the connectivity, that is whether 2 pixels are similar in their values or not. So generally connectivity occurs between the 10 to 15 or 8 to 15 gray levels. If the possible intensity value is 0 to 55, then we set should be any subset of these 256 values. For adjacency, 2 pixels P and Q with values from V are 4 adjacent if Q is in the set N4P. So at that time we can say that it is a 4 adjacent. 2 pixels P and Q with values from V are 8 adjacent if Q is in the set of N8P. Now with the example, this 4 adjacency and 8 adjacency will be cleared. Next is the M adjacency. 2 pixels P and Q with values from V are M adjacent if Q is in N4P and Q is in NDP, and the set N4P and N4Q has no pixel whose values are from V. So this condition is very important. So first we require to check either this condition should be true or this condition should be true. So here the first, it should be the adjacent neighbor or it should be diagonal neighbors, but at the same time the N4P and intersection of N4Q must be empty. So with the example, this formula is very much easy and clear to understand. Mixed adjacency is a modification of 8 adjacency, and it introduced to eliminate the ambiguities that often arise when 8 adjacency is used. So generally it is used to eliminate multiple path connection. Now we can see the different distance measure. Now this is the image patch of 6 by 6. Now these are the pixel locations. So in this direction X increases and in this direction Y increases. Now this is the pixel into the consideration P and Q. Now we will see the Euclidean distance. So Euclidean distance is denoted by DE, and it is nothing but square root of y2 minus y1 square plus x2 minus x1 square. Now the location of the P is 1 2 and the location of the Q is 3 4, which is denoted by x1 y1 and x2 y2. So when we take the distance, that is when we apply the Euclidean distance formula, we are getting 4 minus 2 square plus 3 minus 1 square and the whole square root. So we are getting the distance of 2.83. So when we are applying the distance, then at that time we are not seeing the connectivity, but directly we are seeing the what is the distance between these two pixels. City block distance D4. Now this formula for the city block distance D4 is y2 minus, that is absolute distance of y2 minus y1 plus absolute distance of x2 minus x1. Now here we are taking these two pixels are into the consideration, so their coordinates are 1 2 and 3 4. So 4 minus 2 is 2 and 3 minus 1 is 2. So we are getting 4 distance, and if we see the diagram, so this city block distance is going by D4. So DF4 is nothing but adjacent neighbor. So if we take this path 1 2 3 and 4, we are getting the distance of 4, or we can follow this path also 1 2 3 and 4. So by this way also we are getting the 4 distance. So that is nothing but the D4 distance. Next is the chessboard distance, which is denoted by D8, and this is nothing but this pixel 1 and 2 and Q3 4. So this is nothing but the maximum of absolute difference between the y2 minus y1 and x2 minus x1. So max of 2 comma 2 is 2. So if we see this, for example, chessboard distance, that is go by diagonal neighbors. So we can go from here and next we can go from here. So distance is 2. Next is the DM distance. Now it is calculated with M adjacency. It does not depends on coordinate values, but how connectivity goes from source to destination. Now here we require to find out the M distance between these two pixels, which is indicated in yellow color. Now here we require to consider the V is equal to 2 3 4. Now if we start from 4, then we can go directly 3 because 3 is in the set, but we can't directly go from 4 to 3 because the condition will be that there, for example, this 4 and this 3, their intersection must be empty. Now in 4 and 3, the neighbors of 4 and 3 are 1 and 2, common neighbors. We are seeing the common neighbors. So 1 and 2, and here 2 and 1. 1 is not into the consideration because it is not the part of V, but here 2 is into the set of V. Now 4 having 2 and 3 having 2, so their intersection is not empty. That is nothing but this condition is false. That is N4P intersection N4P must be empty, but here it is not empty, it contains the value 2, therefore the condition is not satisfied. So we can't directly take this path, but we are taking this path. So this is our first distance. After that we are going from 2 to 3. Now here when we are actually implementing, we require to write down a lot of conditions that we should go from source to destination direction only, otherwise this way is also possible. So if we go by this way, then again we stuck up and we will not go to the destination. So this 3, then 3 to 3, the easiest path and the connectivity is okay, and after that we can go to the 2. So total DM distance is 1, then 2, then 3 and then 4. So dm distance is 4. So dm distance is solely based on the V set, that is nothing but the similar regions. Now we will see the exercise one by one. Find d8 and dm distance between P and Q. So first we will find out their coordinates. So P is 0 2, 0 0, 0 1, 0 2. So it is 0 2. This is one row, this is second row, 2 0, 2 1, 2 2. So this is 2 2. D8 distance is nothing but maximum. So 2 minus 2 is 0 and 2 minus 0 is 2. So maximum is 2, and even we can see that we can go directly like this. This is 1 and this is the next. So dm connectivity is 2. Now we require to take the m distance. So for m distance, this is 1. Here we can't take this path because here and here their common pixels is 0 and 1, but 0 is not into the consideration 1. So their intersection is not empty, because in Q this 1 is there, and in this particular pixel, intermediate pixel, again 1 is present. So they are having common 1 element. So we are not taking this path, but we are going like this. After that we are going this way, and here we can go diagonal because their intersection contains 0, but 0 is not part of V. So this path is okay. So value is 1, 2 and 3. We will see the next example. Find the d4, d8 and dm distance where V is equal to 3, 4. Now again we can take the location 0, 2 and 2, 2. Then for d4 we are taking the difference, that is absolute difference. So absolute difference we are getting the 2, and here we can see that by 4 neighbors we can go directly from P to Q. So there it is 2, and if we want to use 8 neighbors we can go directly by this way, 1 and 2. So the d4 and d8 distance is same. Now we require to calculate the dm distance. So for dm, here we can't directly take this path because the 4 is common. For 4 this 4 is there, and for 3 this 4 is there, and it is a part of V. So therefore we can't take directly the diagonal path, we require to follow the 4 neighbor path. So this is one path, then second, then here we can take directly this because their intersection having one element. For example, 1 is there, but problem is that 1 is not the part of V. So we can connect 3 and 4 directly. So dm distance is 1, 2 and 3. Next is following arrangement of pixels. Find the dm distance between the P and P4. So this is the arrangement is given, and V is a 1. So this is the binary image that is contains 0 and 1 value. So P, P2, P4, P, P2, P4, these values are 1. So all diagonals are 1, and P3 have value of 0. So this value is 0. Now the different conditions are given, that is P1 and P3 values are 0. So initially they are 0. Now we require to take P1 and P3 have value 0 if either P1 or P3 is 1. So we are taking all these three conditions. Now see the first condition, P1 and P3 have value 0. So this line comes here. P1 and P3 have value 0. So P1 and P3 have value 0. Now we require to find out the connectivity between these two, this. And as set is a V is equal to 1. So we can't take directly this path. So this path is acceptable because their intersection is empty, and this path is also acceptable. Therefore dm is equal to 2. Next condition, either P1 or P3 is 1. So we'll keep first P1 is equal to 1. So this is 1. So when now we can't follow this path, because if we follow this path directly, then this element contains 1 and this is also contains 1, and 1 is a set of 1. So their intersection is not empty, because for this pixel the n4 neighbors is 1, and for this pixel n4 neighbor is 1. So their intersection is not common. So we are taking 1, 2 and 3. Next is P3, we keep 1. So P3 is 1 and this is 0. So here we can't take, we can take directly this path because their intersection is empty, but after that we can't take this path. So we require to take this path and this path. So again distance is 3. Next, compute Euclidean d4 and d8 and dm distance. All 4 distance we require to calculate. Now here we will take the coordinates. So this coordinate is 0, 3 and this is 3, 0. So with the coordinate we can calculate all the distance. D4 0 minus 3 and 3 minus 0, which is equal to 6. Here we require to take the maximum 3, and here we can also see the distance with the d4. with D4 connectivity, what we require to go by adjacent neighbors. So 1, then 2, 3, 4, 5 and 6. We can go by this way also, that 1, 2, 3, 4, 5 and 6. Now if we say the D8, then we require to take the diagonal neighbors. So distance is 1, 2 and 3. So in this way we can calculate, and this Euclidean distance is nothing but square root of y2 minus y1 square plus x2 minus x1 square. So we are getting this 9, that is square root of 9 plus 9, that is 18, that is 4.24. Now we require to calculate the next is the DM distance. So two conditions are given. First v is equal to 0, 1 and next is v equal to 1, 2. So we will calculate first for v equal to 0, 1. So this is pixel. So if we go in this direction, we will stuck up, so we follow this path. So actually when we are implementing, we require to take a lot of precautions when we are moving from source to destination. So now this 0, okay. Now this path we can't take because their common is 1 and 1 is the set, 1 is the part of v set. So we are taking this path, then this path, and after that we will go directly this path, and here directly the diagonal path is possible because both pixel having the common elements as 2 and 2 is not part of v. So 1, 2, 3, 4, 5, and when we take v is equal to 1, 2, at that time here 1, 2 is there, so we can't take directly this path. So 1, 2, 3, 4, 5, 6, even this path is also possible, and by any path we are getting the distance of 6. Show that the D4 distance between the 2 points P and Q is equal to the shortest path between these points is the path is unique. So 2 pixels are for illustration, 2 pixels are taken. This is 3, 0 and this is 2, 3. When we take the D4 distance, we are getting the answer of 4. That is 0 minus 3 and 3 minus 2. Their absolute distance is 4. Now for 1, 2, 3 and 4. In this way we can go to this path, or 1, 2, 3, 4. We can go directly by this path also. So distance is independent of any path that may exist between the 2 points. Therefore either we follow this path follow, but it is directly calculated based on the coordinates value. Therefore D4 distance between the 2 points is equal to the shortest path between these 2 points. So we can check that multiple paths can be possible, but when we apply the formula, we are getting the shortest distance because it is not following any paths. It is directly just calculated with the coordinate values. Now this is the example. V is 2, 3, 4 is given. First we require to calculate DE, D4, D8. So for that we require to first find out the location of P, that is 0, 0, and this is 0, 1, 2, 3, 4. So the location is 4, 4. D4 we can easily calculate. D8, here also we can see 1, 2, 3 and 4. And for diagonal, for adjacent we can go by this path also or by this path also. So we will get the 8 value, and Euclidean distance is nothing but 4 minus 0 square plus 4 minus 0 square square root, and we will get the 5.66. For DM distance we can follow this path because this path is not allowed because their common elements is 4. So this 1, 2, 3, again 2, 3, this, and by this way if we take 1, 2, 3, 4, 5, 6 and 7. So DM distance is 7. Now next is to find out the distance. So you can easily without doing much more calculation, you can easily find out that we can't follow this path, that is we can't follow this path, so we require to follow this path 1, 2, 3. Here we can follow directly this path, and here also we can't directly follow this path, but we require to go 1, 2 and 3 by this way. So in this way we can find out the connectivity between the pixels. So this is all about the different adjacency measures, different distance measures between the pixels, which we need to find out for the similarity region. Thank you.